Here we have a timeline with cash flows taking place 3 different periods. But this is a little different than we saw in the last video. Okay, here we have $100 at the end of period 1, 100 at the end of period 2, 100 at the end of period 3. The cash flows are equal and they take place at equal time intervals. When you have equal cash flows taking place at equal time intervals, we have what is called an annuity. Solving annuity problems are very simple on a financial calculator, fortunately. First of all, let's kind of review how we did this the horse and buggy way. To find out the present value of these cash flows, we're going to have to do it one at a time. Okay? We've got $100 at the end of period 1. What's the present value of $100 received in one period? Well, $100 is the future value. I is 10, 1 is n, and we solve for present value 9091. The present value of $100 received in 2 years, assuming the periods are years here, 100 is the future value, n is 2. Now you already have the 100 in the future value register. You already have 10 as I. All you have to do is change n from 1 to 2, plug in the 2 for n, and then solve for present value, 8264. And $100 received in 3 periods at 10% would be, just plug 3 into the n register, hit present value, 7513. So the present value of all those cash flows would be just the sum. Add them up. And I get 248.68. What if you had 360 of those cash flows? Every year or every month or every whatever for 360 periods. That would take half the day, and probably you'd get it wrong because probably at some point you hit the wrong button or you added it up wrong. Of course, a spreadsheet doesn't have that problem. Well, an easy way to do it is to use the annuity key. There's an annuity key on the calculator. It doesn't say annuity, but it should. If there were more room, it would say annuity payment. It just has payment, but it really is annuity payment, and that's when you have an equal cash flow over an equal time interval. So let's solve this problem right here using the easy way, the annuity payment key. So we notice that we have an annuity payment of $100. Let's plug in, type in 100 and hit payment. How many of them are there? There's 3 of them. 3 is n. What's the rate of return or the interest rate or whatever, rate of change, whatever it is? It's 10%. Plug that in. Now, we don't want anything in the future value register. We're not using that here. So make sure, just enter a 0 in future value. Okay. All right, now we just hit present value, and miraculously we get 248. Well, I get 248.69. What's the difference? Just a rounding error when I added those up. A lot quicker, a lot easier. Okay, let's do something a little different. Let's figure out the payment on your home mortgage. All right, let's suppose you're borrowing I don't know, let's say $200,000. You're borrowing $200,000 today. So you're getting 200,000 bucks. And you're going to make monthly payments for the next 30 years. So if it's monthly payments for the next 30 years, how many periods is that? Well, there's 12 months in a year. For 30 years, there's 360 months. So the relevant period here is the month. Yeah, let's say 6% interest. 6% interest. But yet that's an annual rate. But the payments are every month. See, how we would say that is 6% compounded monthly. So the 6% is an APR. That's an annual percentage rate. That isn't actually what's being charged. If you were paying 6% per month, you'd be broke. Okay, no one could buy a house. So the way we write that, we have to convert that to what we call a periodic rate. So 6% is the annual percentage rate. What we need is a periodic rate to do this calculation. Well, to get that, we just divide the 6 by the number of periods per year. So our periodic rate is 0.5%. That's the number we use in our calculator. Okay, it's 0.5% per month for 360 months. So what we want to know is what's our payment? How much are we going to have to cough up? I mean, it's going to come out to be a negative number. That means we're coughing up this amount, whatever it is, for 360 months. So what is our payment going to be? Well, let's plug in the numbers. Again, we've solved the problem. We've done the hard part. This is it. It's really over now. We've used the timeline to diagram the problem. And now, mindlessly, we just enter the numbers. Well, not too mindlessly. We want to make sure we get them in the right registers. Okay, 200,000. Change the sign there. That's the present value. 0.5 is I. 360 is N. And make sure nothing's in the future value register. We're not using that in this problem. There are some problems where when we get to bonds, we're going to see all 5 registers. We'll be using all 5 of them. But right now, so far we've only used 4. So put a 0 in the future value just to make sure. Hit payment, and our monthly payment will be $1,199.10. Of course, that's just the part that goes to the mortgage. You're going to have to pay insurance, property taxes. They're going to take that out as well. So, but this is the amount that goes to principal and interest. All right.